This is the 3-7 to 3-8 review. Calculators are not allowed, and this is number 2. With this one, we are trying to find the fourth derivative evaluated at x equals 0 for each of the following. So that means we need to take 4 derivatives and then plug in 0. If I look at A, my first derivative will be 5 times that 3x plus 2 to the fourth times the derivative of the inside, which is a 3. Now I'm not going to multiply this out because I will actually start to see a pattern if I continue. So my second derivative will move through that coefficient of a 5, then it will hit the power, then the inside will be left alone. We'll decrease that power by 1, keep the 3, it acts like a coefficient, it's just at the back, and then we'll multiply by the derivative of the inside again. If we take the third derivative, we will again move through that coefficient, hit the power, leave the inside alone, reduce the power by 1, hit the coefficient at the back, and then multiply by the derivative of the inside. The fourth derivative, we again move through the coefficient, hit the power, reduce the power by 1, keep this at the back, and then multiply by the derivative of the inside. So there's our fourth derivative, and we want to evaluate now at, want to evaluate that at 0. So we're going to plug in a 0, and that will give us 5 times 4 times 3 times 2 times, if I plug in a 0, I'm going to get a 2, and then I have a 3 to the fourth. And I'm pretty sure for my answer, I write that as a 5 factorial times a 2 times a 3 to the fourth. Okay, if we look at part B now, same process. We want the fourth derivative evaluated at 0. So the first derivative, I see the power, I bring it down, reduce the power by 1, multiply by the derivative of the inside. The second derivative, move through the constant, hit the power, leave the inside alone, reduce the power by 1, leave that coefficient at the back alone, and now multiply by the derivative of the inside. Third derivative, same process, hit the power, reduce the power by 1, coefficient at the back squared stayed the same, but now we multiply by another 5. Fourth derivative, notice this time when I bring this 1 down in front, I now have a inside raised to a 0 power, which is just a 1, and then I have the derivative of the inside will give me another 5. So I end up with this case having no x to even plug in. So that fourth derivative at 0 will just be 4 factorial times 5 to the fourth. Last one, part C. Again, we see that fifth power. So the first derivative will be 5, 8x minus 3 to the fourth times an 8. When I take the derivative again, that 4 will come down in front. I'll reduce the power by 1, and I'll get another 8. Take the third derivative, bring the 3 down, reduce the power by 1, get another 8. Fourth derivative, I bring that 2 down, I still have an 8x minus 3 to the 1 power, and I get yet another 8. So this time when I plug in 0, I will have a 5 factorial times an 3 times an 8 to the fourth.